here's an example. Okay, so here is magnesium with different types of isotopes. And what it says here are AMU, we're going to learn about, and we're going to also understand why there are decimals here. So what is AMU? Well, that stands for atomic mass unit. So we're going to be measuring in atomic mass units because atoms are very, very tiny. And what makes up the universe are molecules and atoms. So this is a measurement easy for scientists to measure in atom size and molecular levels. When we see these decimals right here, when I say decimals, I'm saying these. So when you have a percent, it becomes a decimal in an equation, so it's easier to understand. The percentages mean the abundance of each atom. So technically what it's saying is in order to calculate the average atomic mass of an atom, only around 78.70 of a magnesium atom with an atomic mass of 24 atomic mass, basically only 78.70 would actually work and would actually be accurate in order for this to actually work. So basically, we have two things we gotta insert into a formula. We have the atomic mass units, and we also have the abundance in the elements to have an actual huge effect in the average amount of the average atomic mass. So the way we do this, it does look like a formula, but there's all the ways we can see things too. The way we do it at our school is the average atomic mass is going to be equal to the mass of the first object. That is equal to AMU. Then we have to multiply that object by the abundance of the atom, let's say 70.70. That is the percentage of the abundance of the atom. And divide that by 100 to get another decimal. When we do that, depending on how many experimental different elements, different atoms, the same elements that have different atomic masses, then if we wanted to add a second one, we have to add that by the mass of the second object in AMU. Then we have to multiply itself by its own atomic mass units and divide by 100 to get a decimal, and so on. We can add as many as we want, so let's get started. So the average atomic mass would happen when we get 24 as the atomic mass for magnesium, 23.99 atomic mass units. So 23.99. Then we have to multiply that by 78.70 as a percentage in abundance to actually have an effect for this type of math work. Then we have to divide by 100. Then we have to add that by the second object, which is magnesium 25. That is 24.99 atomic mass units. So the atomic mass units will be around the number for this right here, but it's rounded. So we're going to put 24.99. Then we have to multiply that by 10.13 because only 10.13 of magnesium 25, AMU 24.99, would actually have a huge effect. Divide that by 100. But not only that, we have to add that by our third element, our third magnesium 26. So now we have to do 25.98 AMU. That is rounded to 26. Then we have to multiply that by 11.17, and then we have to divide that by 100, and we shall get an answer. So when we do 24 magnesium, when we do this by that, and do the math for that, we get 18.88 AMU. The reason why that happened is, since magnesium 24, since this only particular atom that we measured and grabbed out from somewhere, 23.99 is the atomic mass unit for that single magnesium atom. But the reason why we have to multiply by a percentage and divide by 100 is because only 78.70% will actually make a big effect on it. That is sort of like the variable for, that is sort of like the formula that drives it to the answer. So this is our answer for magnesium 24. Magnesium 25 would be, when we get the answer, 2.531 AMU. Notice how we do round to 3 decibels max. And 26 AMU, 26 magnesium, that would bring us to 2.902. Then when we get an answer, we have to sum up all of the AMUs, the atomic mass units, to get to an answer. And we get 24.31 atomic mass units. We can check on the periodic table, but don't go crazy if we get some decibels wrong or decimals wrong. Take a look at magnesium, and we get around 24.3050. We got 24.31. Why are we a little bit inaccurate? The reason why is, we said it earlier in the periodic table that this mass number for magnesium represents all of the magnesium elements in the universe that we know of in an observable distance. The reason why we got the average amount of atomic mass a bit off is because we only focused and locked on 3 different magnesium atoms with different isotopes and different number of mass numbers and different neutrons. We only focused on these. But if we focus on all of them, which is hard to count like stars, like 1, 2, 3, 4, well, then we would get this answer right here, the average of all of them. We got this because we only experimented with 3 of the magnesium atoms. And that is how we can calculate and understand the average with the mass number. So, thank you for watching Top Opinion Life's Math Industry. Like and subscribe.